This is the bevel surface of a relatively unused single fiber electrode, demonstrating how the insulating material can extrude from the inside of the cannula, and this must be periodically either wiped off with a fine emery cloth or ground off against a fine grinding stone. You can also see how the tip of the electrode is shaped, and this shape must also be periodically maintained by slight grinding. Here's how the shaft of the electrode is polished by gripping it in a fold of fine emery cloth. The electrode is twisted and moved in and out to polish the shaft of the needle, and in so doing remove from the recording surface and from the tip any debris or extruded insulating material. The electrode tip must be periodically sharpened, and this is performed under direct observation using a dissecting scope and polishing against a fine Arkansas grinding stone. Only very slight amount of grinding is necessary to remove hooks from the tip of the electrode and also to reshape the sharp point. The flat beveled surface is ground at an angle of approximately 20 degrees, and care must be taken to grind only very small amounts with very light passes over the stone. This is an electrode that has been resharpened many times and has become not only short but very blunt to the point of being virtually unusable. After the electrode has been polished and the tip sharpened, the recording surface can be electrolytically cleaned by passing a very slight amount of current through it using a device such as this. This box contains a 12-volt battery and an ammeter, and the single fiber EMG cable is plugged into one side of it. Also connected to the box is a monopolar needle electrode which serves as a reference. The monopolar needle itself is inserted through the side of an inverted rubber cap off a reusable injectable medication bottle containing a drop or two of saline. The single fiber EMG electrode tip is then dipped into the saline, and the process is observed under the dissecting microscope. When the switch on the box is pressed, current is passed through the single fiber electrode, which produces small bubbles of hydrogen on the side recording port. Care must be taken to pass only enough current to generate one or two bubbles at most. This is another device that can be used to pass very small amounts of current through the electrode. This box also contains a 12-volt battery, and the single fiber EMG electrode cable plugs into a connector on the top. The saline well is attached to the top of the box, and the tip of the single fiber electrode is inserted into the saline in the well. Pressing the switch on the box sends a predetermined amount of current through the electrode, just enough to generate one bubble of hydrogen. When the circuit is complete and a hydrogen bubble has been produced, there's an audible beep. With this device, it's not necessary to observe the process through the dissecting microscope. Electrode care is indicated whenever the tip becomes dull, it becomes difficult to insert the needle, or it's more painful, or one sees injury currents in needle insertion. Electrolysis of the recording surface is indicated whenever the signal to noise ratio deteriorates, making it difficult to record clean signals. With proper care, electrodes can be used dozens or even hundreds of times and last for many years.